Hi, and welcome back to Algebra 1. Our goal for today is to continue working with our linear relationships with a more complex scenario, which is called a system of linear equations or a system of linear inequalities. And we have multiple methods for going about solving these, what are called systems of linear equations and inequalities. However, right now we are focusing on our graphing methods for our linear relationships. So we're going to be looking at this top method, how we go about graphing a system and finding the solution or solutions to that particular system. So for today, we're going to start with our linear equations. And later on in this module or in this unit, we'll look at how to solve our systems of linear inequalities using our graphing method. So a solution to a system of linear equations is an ordered pair that is shared by two or more equations. These systems are a series of equations that are one big problem, and we're looking for a place or a point or an ordered pair that satisfies every equation in that particular system. So we're going to focus primarily when there's two lines in our system or two linear equations in our system, which means our solution is that magic place where our two lines intersect or cross with one another, because it is the point that works for both parts of that system. So for example, if I have a system that creates a graph that looks like this, right, where the blue line is its own equation and the red line would be its own equation, and together it creates one big math problem called a system. And our goal is to find a point or points that satisfy both equations at the same time. And that place is right here where our lines intersect, right? That point is a solution of this red line, and it's a solution of the blue line, which means it would be an answer to the entire system that includes both equations. So our solution is that location, which is 1, 2, 3 to the left from the origin, which is -3, and up 1. If we had this particular system of linear equations, we're looking for the point that works on both the blue line and the red line, which is right here. It just happens to be the y-intercept of both lines. So the point that satisfies both equations, which is the system or the solution to the entire system, is the point up 2. So don't go left or right, 0, 2. This particular system of linear equations, again, we're looking for the point that satisfies or is a solution to the red and the blue line, which is this place where our lines cross or intersect. So 1, 2, 3 to the right, up 2 would be our solution to this particular system of equations. So our goal for today is, if I'm given a system, can I create the graph? And then using the graph, can I find that ordered pair that is a solution to the entire system? And it's always going to be that place where our lines cross or intersect, because that is the only point that works for both lines in that system. So our steps for today: graphing our system and finding the solution by locating the place where our lines cross or intersect. Now we have a bunch of methods that help us graph our linear equations. We've talked quite a bit now at this point and picking the better or quicker, easier methods for depending on what type of linear equations we're presented with. So you want to keep that in mind as we work through these problems. Try to resort back to what would be the quickest, easiest method to get our picture version of our solutions, which is our graph. Make a special note there while you're filling in your blanks here that any lines that are parallel, right? So if we have two lines that are parallel creating a system, there would be no real solutions because there would be no point that satisfies both equations in that particular system, right? So if I have two lines that look like this, right? Railroad tracks, right? They're parallel. They don't cross or intersect. That's when we have a special case where there are no solutions. If we're given proportional relationship form, slope-intercept form, or function notation form, slope-intercept method is our quickest, where we use our slope and our y-intercept. If we're given standard form, I can still go to that slope-intercept, or I could do a quick little table with the intercepts. And then point slope, I would use the point and the slope that I know from the ordered pair here in the problem and the slope here in our problem. Or again, I could rearrange it to y equals mx plus b and graph from there. If I have x equals and y equals lines, again, I would go to a table. It works all the time, where some of those other methods don't work. So when in doubt, have just x or just y, resort to that table of values method. All right, in our packet, let's look at example number 1. All right, we want to solve the system that can be described, right? It's, even though it looks like 2 problems here, it's one big math problem together, right? So if we were to graph y equals x plus 3, and if we were to graph y equals 2x plus 3, what ordered pair would satisfy the entire system, or where is the point where those 2 lines cross? Because it is the only point that works for both parts. So let's start with our y equals x plus 3 line. It's in slope-intercept form, so my suggestion would be using that to help you graph. So y equals, there's a 1x here. So m is 1 over 1, or we can use negative 1 over negative 1. And our y-intercept point is at 3, or 0, 3. So let's use those 2 things. Let's start graphing our first portion of our system. So up 3, and then from there, rise up 1, run out 1, rise up, run up, rise up, run up, or drop 1 over 1, drop 1 over 1, and so on. All right, we're going to connect. It's an equation, so it should definitely be a solid line. And my suggestion is put as many points as you can so that your, let me go back and erase because I got a little bit off there. If you graph as many points as possible for this first line, so let me go back up here. It'll help you, hopefully, find the one that the 2 lines share a little bit better. You got to be very accurate when you draw in these lines here, because you're looking for a specific location where your 2 lines are going to cross. Now, it might not be a dot that you draw, but putting as many points in here on this first line as you possibly can will help you find that place of intersection a little bit better, because your line will be drawn really well. All right, now, we're only halfway done. We did this portion of our system, so we have to do this second part, y equals 2x plus 3. All right, it's also in slope-intercept form, so let's go ahead and use that. 2 over 1, or we can use negative 2 over negative 1 for our slope. And our y-intercept here is also at 0, 3. Now, this is kind of a special case because our y-intercept here is also at 3. So that's going to be our location where our lines cross. All right, so from there, let's go up 2 over 1, up 2 over 1, up 2 over 1. So we can get our line in there. Since we are using graphing method, we want to go in and graph and draw in our other line down to the left 1, down to the left 1. All right, and we can draw in our second line. And in this case, our y-intercept just happens to be our place of intersection. So we think our solution is at 0, 3. All right, so at this point, we've identified our answer solution to the entire problem. Entire system is there's one point that works for both equations, and it's at 0, 3. So what I'm asking you to do last is to check and make sure you're right. And the way you would check is, this is an ordered pair of x, 1. It has to check here and here, not just one or the other. It has to work in both of the original equations, or you know you made a mistake. So does 3 equal, right, this is our y, this is our x, substitute in. Does 3 equal 0 plus 3, right? We're checking, does it equal with a question mark. So 3, do our add here, yep, it works there. So we know it's on that line, but remember, it has to be on both lines. So let's check over here. 3, does it equal our 2 times 0 plus 3? 3, does it equal 2 times 0, 0 plus 3? 3 equals 3. Yep, we're good. Since both of these worked, we know that 0, 3 is the point that satisfies that system called the solution. All right, let's try another. Number 2. We want to solve this entire system. Y equals negative 3x plus 2, and y equals x minus 2. So let's start with our top line there. Y equals negative 3x plus 2. Again, it's in slope-intercept form. So let's go ahead and use our m here and our b here. So slope of -3 over 1, or we could use 3 over -1, and a y-intercept of up 2. So 0, 2 is a point we know in our coordinate plane. So up 2 in our graph. And then from there, remember, down the mountain here, down. So down 1, 2, 3 to the right 1, down 3 to the right 1, down 3 to the right 1, down 3 to the right 1, or we go up 3 to the left 1, up 3 to the left 1. Again, my suggestion would be get as many of those points in there as you can so that when you go to connect with your ruler, you're as accurate as possible. Because the place where it crosses might not be one of those dots, but it has to be a place on the line. So you want to draw your line as accurately as possible. All right, now we got to repeat that process for our y equals x minus 2 because we're looking for a specific point that works for every equation in the system. And the way to do that is to graph both and find where they intersect. All right, this is also in slope intercept. So m of 1 or -1 over -1, and a y-intercept here of -2. Be careful, this sign goes with this number, or do your cube change to get y equals 1x plus -2, where that's a plus b back there. So 0, -2 is a point we know. So starting at -2, and then from here we're rising up 1, running out 1. So in this case, as soon as we rise up 1, run out 1, we see that this is our place right there. That's where they cross or intersect. So we go down 1 over 1. We have enough points here. We can connect our line. And we now also think we know that our solution is this guy here at right 1, down 1. So we think 1, -1 is our place that satisfies the entire system, right? It's the one point that works for everything in the problem. So let's check it. Right? It's got to work in both. This is y, this is x, so be careful. So -1, does it equal -3 times 1 plus 2? So -1, does it equal, do our multiply here to get -3 plus 2. -1 equals -1. Yep, we're good. All right, so it works on that line. But remember, it has to work for both. It has to work for all parts of the system, not just one. So -1, does it equal our 1 minus 2? -1, yep, it works. We're good. All right, it worked in both for both lines. So we know that that's the place that is shared by all parts of the system, which is called the solution. So good final solution here of 1, -1. All right, number 3. All right, we want to try to solve this entire system. It's made up of 2 linear equations of y equals 5 and y minus 3 equals 2/3 x. So let's start with our y equals 5 line. Excuse me. Let's get rid of that guy. I don't need it. All right. So y equals 5 is a special case, right? There's no x. So my suggestion is make a quick table of values. So x, y, where y always has to be 5, 5, 5, 5. We've been using -1, 0, 1, and 2 on the other side, but again, you can do others. So we now know points of -1, 5, or 0, 5, and so on. Use those points to help you graph your line of y equals 5. Remember, y equals lines have 0 slope, 0, so be careful. All right, so up 5, 1, 2, 3, 4, 5. All right, to the left 1, up 5. Don't go right or left, up 5. 1, 5, 2, 5. Those are the 4 we just did in our table. So we want to connect that line. Now, right away in my head, I should be saying, all right, my solution better be something 5, because y I already know has to be 5. So we still need to find this x. And the way that we would find the x of our solution is by working with that other equation to see where it crosses our y equals 5 line. So let's go to our y minus 3 equals 2/3 x line. Now, this isn't really in any format. It's an unsimplified slope intercept. So let's go ahead and solve for this y by getting rid of this subtract 3 by adding 3. So 1 minus 3 plus 3 equals our 2/3 x plus 3. All right, cancel. And now we see that it's in its simplified slope intercept form. So our slope here is 2/3. Or a -2 over -3, and our y-intercept is at +3, or 0, 3. All right, so let's try to graph our second line in there. We need to figure out what is our x value when our y is 5 for this particular line. So up 1, 2, 3 on our y-intercept. And then from here, rise up 2, run out 3. So up 2, 1, 2, 3. Here's our spot we were looking for. That's our good one. All right, down 2, 1, 2, 3. Right, we need enough points here so we can draw in our second part of our system. Make sure we're going past our points. Again, we're not drawing this little baby segment here. We have to draw our entire line. All right, so we think this 1, 2, 3, 5 is our place where our lines cross. So we think our solution is at 3, 5. Remember, it's got to work in both. So let's run our test. All right, this one only has, remember, this is x, y. This equation only has a y, so 5 equals 5. We knew that was good, right? Over here, we have to check both. So 5 minus 3. Does it equal our 2/3 times 3? All right, 5 minus 3 would give us a value of 2. 2/3 times 3. Actually, let's cross cancel, leaving us a 2 here. We're good at checks. So our solution here was 3, 5 is the point that works for both equations in the line called the solution. All right, example number 4. All right, we want to solve the system of linear equations when we have y equals 2/3 x plus 5 and x minus 6, right? This is one big math problem that goes together made up of 2 individual parts. So let's start with our y equals 2/3 x plus 5. It's in slope-intercept form, so we can use our slope of 2/3, or -2 over -3 is the unsimplified sign version that we could also use. And our y-intercept of 5, which remember is really the point 0, 5 in our coordinate plane. So we're going to go up 5. And then from there, we can rise up 2, run out 3, rise up 2, run out 3. Again, I'm going to put as many points as I can. I want to draw this line as accurately as possible so that I can find that place where my lines intersect as best possible. It might not be one of the dots I just drew to help me draw the whole line. But the more points I put in, the more accurately I'll be able to draw the line to find that magic place where they cross. All right, now we know our other line is in x equals 6. So we're really looking for 6, where's our y when we draw that other line? So let's go ahead and let's look and see what happens here. So we have a special case with just x. So I would make a quick little table of values where x is always 6. We've been using -1, 0, 1, and 2 for the other side of our table for these special cases, but you can use any point you want. Now that we have some points, for example, we're going to go to 6, -1, plot a point, 6, 0, plot a point, and so on. We can draw our other line. So to the right, 1, 2, 3, 4, 5, 6, down 1. Don't go up or down, up 1, up 2. And so we can take that and help us draw our other line in here. And we see that this point right here is the one that we think is our good final crossing spot, which means it's the point that is the solution for the entire system, right? It's the only point that works for every part of the system. And so that point is at 6, 9, right? We know this x equals 6 had to be 6. All right, so we want to check and see if the 6, 9 works for the other equation, right? Because checking this one over here, 6 equals 6, that definitely works. So let's check this guy over here. 6 in here for x, then 9 in here for y. So 9, does it equal 2/3 times 6 plus 5? All right, 9, does it equal, multiply first, 2/3 times 6 would give us a value of 4. So 4 plus 5, and if you can't do that math in your head, that's okay. Use your calculator. 2 ABC 3 times 6. So we end up here 9 equals 9. So we are correct. It is the solution of our line, which it means it works. And it is the ordered pair that is the solution to the entire system of equations. All right, that should help you attack your work for today. See you guys later.